Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel. So today we're going to be continuing episode 4 of the series of differentiating or deriving trigonometric functions using the product rule. And episode 4 is the fourth question. Just like you guys who've been following my videos on this channel know that each particular video is basically a question by itself, and each question is seen as an episode, and the entire series is just the whole package of that particular topic, or subtopic. So the first thing I want you guys to do is to make sure that you have the information on the screen right now. Like the information is just basically trig notes, right? And so like whenever you're doing derivatives, or just basically you applying trig expression, trig identities and all of that stuff, it will be very important for you to have what is on the screen right now. So I think you guys should have it, and you should keep it for the entire series if you don't already have it. And I'm sure students who've been watching the first 3 videos of the series probably already have this, because I put it at the front of every single video, and I plan to do it for every single video going forward as well. So please have this note and keep it and use it as we go along the series. So for this video, our question is f of x equals sine x cosecant x. So now the first thing we're going to do is to quickly do a review of the product rule. And the product rule basically is applied when you have 2 sub-functions, usually f of x and f of x and g of x, and 2 sub-functions that are multiplied by each other. And when you want to derive 2 sub-functions, f of x multiplied by g of x, which is what the general expression or equation looks like. But in this particular case, we have sine x multiplied by cosecant x. So this one is basically the general equation. Like when you see something looking like this, 2 sub-functions multiplied by each other, then you already know we have to apply the product rule in order for us to differentiate it. Now, to differentiate it, that we apply the product rule, this is what it's going to look like. Derivative of f of x, of the large f of x, equals the derivative of the first sub-function, which is the small f of x, multiplied by the second sub-function, plus the derivative of the second sub-function, g of x, derivative of g of x, ddx, multiplied by the first sub-function, so small f of x. So when you can have this, then you can start applying. So the next thing you have to do now is to compare first of all compare your question, and also compare your question with the general equation. In this case, f of x in our question is going to be equals to sine x, and then g of x is going to be equals to cosecant x. So one thing I wanted to mention, and I've been mentioning it through the series, is that anytime that you're given a question that requires you to apply the product rule, just know that the position is not as important as you may think it is. Meaning, if we apply the product rule to sine x multiplied by cosecant x, is the same thing as applying the product rule if we switch the position of sine x and cosine x. So basically, when we have this question, sine x multiplied by cosecant x is the same thing as cosecant x multiplied by sine x. So if we apply the product rule, we're going to get the same answer. But for the purpose of calculus and for the purpose of us having consistency in our work, it is best for you to basically follow the position of the question. So that means if the first sub-function that you're given is a particular thing, make that to be f of x. If the second sub-function is a particular thing, make that to be g of x. So in this particular case, if we had the question cosecant x multiplied by sine x is the same thing as saying cosecant x equals f of x. But the answer is going to be the same. For the purpose of calculus, we're going to try to be consistent. That's my point. But one thing again is, if you decide and you make a mistake and you switch it, you're still going to get the answer. I don't think your answer is going to be wrong. I know your answer is not going to be wrong. Thank God. But one thing you should know is stick to the positioning so that at least you don't confuse your teacher and you don't confuse yourself. So, yeah, so f of x equals sine x and g of x equals cosecant x. So now let's do the derivative of this. Derivative of sine x cosecant x is the same thing as derivative of the first subfunction, and in this case that's sine x. So ddx of sine x multiplied by the second subfunction underived, and that is going to be just cosecant x, just chilling by itself, plus the derivative of the second subfunction, so derivative of cosecant x multiplied by f of x, the subfunction, which is just sine x. So I put sine x at the bottom if you can't see. So the next thing is going to be, what's the derivative of sine x? Now let's go back to the first part of the first screen that we had at the beginning of this video. So you can see here that I have the derivative in red. So everything that is a derivative is red, like derivative of sine x, derivative of cosine, derivative of tan x, derivative of secant x, derivative of cosecant x, and the derivative of cotangent x. You can see all of this, right? I have it in red, and then every other like trigonometric expression, or in this case trigonometric identities that I have up top to the right, I have all of them here to guide you and to assist you as you go through the series. And in this particular problem, obviously we're gonna have to use it. So now they ask, what is the derivative of sine x? We come here, the derivative of sine x is cosine x, so we can put cosine x here, and then multiplied by cosecant x. Because we're not doing anything with the second subfunction in the left side of the plus sign, we're just going to drop down cosecant x, because we pretend like as if it's a constant, meaning it's not really doing anything. We're not deriving it. We're not doing anything with it, to be honest. So it just comes down. Plus, what's the derivative of cosecant x? Let's come back. Your cosecant x is negative cosecant x cotangent x. So derivative of cosecant x is equals to negative cosecant x cotangent x. So let's put that down. And by the way, it's here at the bottom here, bottom left of the page, that is shaded, that has a shaded underline. So that one, so we have plus negative cosecant x cotangent x, and that multiplied by sine x. Now let's go to the next page. Cosine x cosecant x plus negative cosecant x cotangent x multiplied by sine x. So the next thing you have here would be multiply everything. So we have cosine x cosecant x. By the way, the stuff up top is just me rewriting what was at the bottom of the previous page. So minus here cosecant x cotangent x sine x. So the thing that we can do in this particular question is, the first thing we can do is we first of all write cosine x and we remember that what is cosecant x what is that equivalent to? Let's go to the previous page for us to see. we know that cosecant x, right, is the same thing as 1 over sine x. Cosecant x is the same thing as 1 over sine x. When you look at the trigonometric expression, we see that, for example, sine x is equals to 1 over cosecant x, cosecant x is equals to 1 over sine x, or in this case, so in this case, we're looking for what cosecant x is equals to. Go to the page where we want to apply it. Cosecant x equals to 1 over sine x. So keep that here. Minus cosecant x multiplied by cotangent x multiplied by sine x. What did we say cosecant x is equivalent to? We say it's 1 over sine x. So we're just going to repeat what we did. And then, what is cotangent x? Let's go to the previous page. Cotangent x is the same thing as 1 over tangent x. I'm at the bottom where they say cotangent x equals to 1 over tan x. But cotangent x is also equal to cosine x over sine x. So we're going to do that here as well. Cosine x over sine x multiplied by just sine x. Now, before we go forward, let me teach you what's going on here. You see this answer right here that I am drawing, I'm putting in a red box or red rectangle. This answer is okay, it's sufficient. But whenever I do trig functions or any question regarding trig, this is just a habit that I've come to do consistently, is that I try to make my work as neat as possible. Cosine x multiplied by cosecant x minus cosecant x cotangent x sine x is okay. That's the answer. But because I've already gotten used to me making sure my work is neat and able to work with a neat work, I do not like my work being all messy and stuff like that. So I like to convert or transform trig information like cosecant, cotangent, secant. I like to transform them to other forms where I can easily cancel out things that can be easily cancelled out. So in this case, that's what I'm doing. So here we have sine x, we can cancel that out, right? And then we have here cosine x divided by sine x. Okay, so now we have cosine x over sine x minus, now we have cosine x, this is left from the previous cancellation, this is left and this is left too. So we have cosine x over sine x, and voila, what do we have? We have a 0. So our answer ends up being 0. So this one is okay and correct. This one is also okay and correct. You can see the reason why you have to be very consistent with you have to try your possible best when you're dealing with trig, because this entire thing, cosecant x multiplied by cosine x minus cosecant x cotangent sine x, is the same thing as being equals to 0. So both answers are okay, and I would advise that you follow my style of converting trig expressions to be able to cancel things out, or factor trig information just to make your work neater and to have a more concise result or answer. Now I want to quickly teach you guys something. If we go back to the beginning of the work, we said sine x multiplied by cosecant x, right? And we have to find the derivative of this. Now, before we do that, one thing you guys should know is sine x multiplied by cosecant x. What did we say cosecant x was before? We said cosecant x is the same thing as 1 over sine x, right? If that's the case, 1 over sine x, we have 1 over sine x here. And now we're doing the derivative of this information here, right? Now, sine x multiplied by 1 over sine x is just the same thing as the derivative of us trying to derive 1. And at this level of calculus, I believe everyone knows that derivative of a constant, no matter the magnitude or size of the constant, it doesn't matter whether the constant is 1.7 gazillion or billion, or it does not matter whether it's a fraction, a decimal, or a derivative of a constant or a whole number. The derivative of a constant is always 0. Always 0. So you can see that this is a shortcut way of even doing the whole thing we just did. This is literally a shortcut way. So if you're in an exam and you're given this stuff, you know that you can break it down and you're still going to get the answer. We have 0 here. The previous page we also have 0. So that's the short thing I wanted to teach you guys today. I wish you guys all the very best. And yeah, that's what I do. I wish you guys all the very best. If you like this video, please hit the like button. Make sure you share this with your classmates or anybody that you know that is struggling with doing trig functions and product rule and all of that stuff. Make sure you ask questions. And go into the description box. I have a whole playlist and I have directions on what to do and or what to do with this video. And just basically go to the description box if you need any help with anything. You can please subscribe to my channel. Go to the description box again if you want the playlist to other related videos or videos that will help you if you're taking calculus. And that's about it. So I wish you guys all the very best and take care of yourself. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Alhamdulillah.